So guys, continuing our quest from tomorrow. Today we will be looking at model building. So let's start today's session. So first thing first, we need to load our data set. So if I click to the data set, then you can see that we have this particular data set available for us, right? So we will be using this data set for our model building. And as you can see, most of the values are pre-processed by default. So you don't need to work on that. Okay. So to load our model, we will simply do, first of all, an import pandas pd and import numpy as. Once we are done with that, we will load our data. Okay. So next is data. It's equal to pd dot read underscore csv, and then we have to pass in the file name. The file name is npp1 modelbuilding.csv. Okay. So that's I'm going to pass here, and we are done. Now let's check a few values here. CSV. Now we have our data, and you can see that these are our column labels and these are our row labels, right? And we will be using this extensively throughout this particular lecture. Okay. Now let's start solving some of the questions. So our first question is, which dataset are you using for this exam? So we are using this particular dataset. So I'm just going to copy it here and paste it here. But obviously this will be a multiple choice question. So you have to just pick whatever is that. Now for the second, it says split the dataset into train and test in the following manner. Use train test split to split the data into train and test dataset with size equal to 0.3, that is 30%, and random state equal to 40. Let other parameters have default. Column except the last column should be feature matrix xtrain or xtest. Last column will be label vector. So in this particular question, everything is mixed up. You don't need to do in the same order as it has been told. You have to first separate them for the feature matrix and column, and then use train test split. Okay, else you will have issue. And the best way to do it is using ilog. So ilog basically allows you to do index based location accessing, and these are your indices, right? So based on that you can do. So for the last column we will remove this, and for the target we will be using. Let's do that. It's very simple. First, create a variable x is equal to data dot ilog, and the way the ilog works is you have to pass your true index and end row index, comma, start column index and end column index. So since we need all the rows, basically all the observations, and we want all the columns except -1, so we will be doing -1 here. Okay? And this colon means all the value. -1 we are doing this because it will get excluded by default as per what ilog works. Okay. So y is equal to data dot ilog, and again you have all the rows, but now you want to start from the last column itself. Okay. Now if I do x dot shape, y dot shape, you will see that we have these values, right? It's always good to check your number of samples for x and y so that you don't have any issues later on. Now we can do our train test split. So for that I am going to import train test split first of all. So for that I will be doing from sklearn dot model underscore selection import train test split, then xtrain test y test is equal to train test split x comma y comma test underscore size, which will determine what will be your test data size, which is for us is 30%, but you have to input it in values between 0 to 1. So we will be passing 0.3 comma random state is equal to 42, and make sure you do this particular thing for the value that is here, right? Else it will cause an issue and you will lose marks. Okay. So this 42 is given here. So that's why I'm using this. And now if I try to check the training features and training labels, you can see that they are evenly distributed. Similarly, for xtest also you can do. So testing features and testing labels, you can see that we have same number of observations, and comma basically means that it's a series. Okay. So once we have done this, we can move on to our second section of this particular question, which is training a ridge model on training data with following parameters. Okay. So first of all, we need to import our ridge model, right? So what that we will do from sklearn dot linear underscore model. So basically ridge model is nothing but a part of linear regression. So it will apply ridge classifier, that's all. So that's why we can do from linear model import ridge. Once we have this, now we can create a model named model ridge, which will take the ridge object itself and then pass in these values which are given to us. Okay. So first we need to pass in alpha, right? helper is equal to 10. It is always good to have this particular setup so that you can see what all values you are passing. So solver is the parameter saga, and then you have tolerance is equal to 1e minus 4, then random state is equal to 40, right? So this creates our model object itself, and now we can fit our data, right? But before that, let me show you what this model looks like. So you can see that it is this, and you can click on here to go to the documentation or refer here so that you can see that it's fitted or not. Fitted means basically trained or not. So we will be using model dot underscore ridge dot fit, and then pass in our trains features and train labels. So that will be like X train, comma, Y train. And once we do that, you can see that the color has turned blue and it means it's fitted. Now we need to check the score. Now there are multiple ways to check the score. So you can use any one of them, but I am going to show you both the ways. So first of all, for later use cases, we will be importing a R2 score from the metric itself. So sklearn dot metrics import R2 underscore score. Let's check. Okay, so sklearn. Now it's imported and we will be using it later. But first way is directly use model.s. So it will by default return you the R2 score itself. So model underscore range dot score, and where we want to test it on our test data, right? So X underscore test, Y underscore test. And once I do this, you can see that this is our value which we want, right? But you can also get the same score by doing a little bit of processing, that is Y underscore spread is equal to model underscore rich dot predict, because we are predicting on our test data. So X test. Now we have our prediction values, and then we can use this prediction and actual value to compare. So R2 underscore, it will take our inputs. So input will be our Y test itself. First of all, that truth, and what is the predicted value, right? That thing also you can. Now you can see that even though I have commented, we are getting the exactly same value. So you can use whatever you want. I just showed you the way. Both will give you the same app. Okay. Now next move on to what is the index of most important feature. Note that index start from 0. Ignore the intercept for this question. So which are the most important feature that we need to find, right? So by default, if you see the documentation of this particular range, you will find that there is a member variable called coef, which is an ND array of say fitna and targets, right? It is just the weight vector, and weight vectors are what defines the importance of the feature, so that you multiply your feature with the weight to give the importance. So we will be using that here. So for that, I will be doing model underscore range dot coef underscore, and you can see that there are negative values and positive values also, but they are not sorted. So for that, we will do np.argmax, which will be giving us the argument maximum and then passing this particular model coef here. And now it says answer is 10. But here you need to consider the absolute value itself. Okay. If we take the absolute value itself, then you can find that 0.4825 is the least value and 23.51 is the maximum value. So as we have taken our values as absolute values, this will be the most important feature because the value for the absolute value is number. So this value will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 9. Similarly, for this least important feature, again, we are going to do this only. You can see that 0.48 is the least. So that means our index 0 is the least. Okay. So I hope that you understand this particular thing. So this concludes our first section, which was a very basic intro. Now let's move on to our next section where we will look at more stuff. So let's look at instructions again. And it says, take a SGD regressor random state 42, estimator with grid search CV, and hyperparameter tuning to be done over the following parameters. For example, penalty, alpha values, and toll. All these are part of your SGD regressor, while cross-validation, scoring, and negative are part of grid search CV. Okay. And you have to use the best model from the above hyperparameter tuning process to answer the upcoming questions. So here you have to create two particular objects to use it for all these steps, right? So mostly first you need to follow the instructions and do things. So first of all, we will import. So for that, we will do from sklearn dot linear underscore model import SGD regression. So basically all the linear models which are for regression type comes under the base class of SGD regressor. And next we will use grid search CV. So for that we will look at sklearn dot model underscore selection, because it helps us to select model. That's why it's model underscore selection. Import grid search CV. By the way, I got this by pressing the tab. Okay. So once we have imported it, we have to create the instance of model. First of all, I will do model underscore SGD is equal to SGD regressor. And then we just need to pass random state 42. Okay. Nothing else you need to pass. Rest all will be done by our grid search CV itself. Okay. So random state is equal to 40. So this marks our model creation, and then we will look at creating the parameter grid so that grid search object can be fitted. And this parameter grid is nothing but a list of key value pairs where key are your parameters name and values which we want in a list. Okay, so it can iterate over. So I will write params underscore grid is equal to all the parameters which we require, right? So this is a very good way to do this, and sadly I have to write it from here. Penalty is equal to first L1 L2. Make sure you use the exact values which are present in the documentation itself, and you can refer to documentation using the method I have shown you earlier, so that you don't cause any issue while fitting this, right? So for example, alpha values will be not there, it will be alpha. Okay, so you should know these parameter names, else it will cause an issue. And obviously you can use the documentation. So alpha will be like whatever values are given here. So they have been kind enough to give us this list so that we don't have to do a lot of work. And then we have our tolerance, right? All is tolerance of how much what you can tolerate the error. This is again here and this is here. So these are done. So these are our parameter grid, basically all the values which are part of our SGD regressor search space. Okay, now we will have to initiate our grid search object so that we can fit this particular thing and do a hyperparameter div. Okay, so grid search, I will write grid underscore search is equal to grid search CV, pass in the values. First of all, an estimator. So estimator is nothing but our model. So model SGD, and estimator means basically which can estimate the parameters. Then we need to use all these cross validation and negative mean absolute error. So for that I will do EV is equal to 5 as per the question, and scoring is equal to negative mean absolute error, which is from here, and it is the exact name. So make sure that you follow the exact name. Also you need to pass your parameter grid. So for that we will be doing param grid, right? Whatever we have defined earlier. So we will be doing that. And once we are done with this, we have our grid search object, and now we can fit our grid search. But let me first show you what grid search actually returns. So you can see that it returns all the values inside a grid search, right? And CV basically allows us to use this parameter CV. Okay, if you use normal grid search, it will not allow. So make sure that you follow the instructions which are at the top. Okay, now let's fit it. So grid search dot fit, and we will fitting it always on our training features and training labels. So X train is our training features and Y train is our training labels. So that I have fitted, and now we will store our best model. So for that we will do best SGP model is equal to grid search, which is our this particular instance has a temporary variable called test estimator, and it will store the best estimator itself. Okay, so this will store our best estimator. Now let me show you the best values. It took a lot of time because these are the values which grid search CV will go upon. So there will be 2 into 5 into 5. So that many combinations it need to check, but it is pretty fast also. And it's again fitted, and you can see that SGD regressor best model values are right. Now based on this, we will solve our questions. Okay, so question 5 says, what is the best penalty? So by default, if you see, you can't see it here, right? It is not there. But since you have used penalty in params grid, you have the power to use get params method and then get the special parameter name, because get params return dictionary, right? So let me show you that. So since it is our model which we want from the parameters from, so best SGD model dot get underscore params. If I do this, you can see that these are just key value pairs. So we just need the penalty. So we will do penalty, and it's L2, right? So this is question number 5. Now let's move on to question number 6. Question number 6 is, what will be the mean absolute error on the test data set? You can use the mean absolute error function itself. So I will first import it from sklearn dot metrics import mean absolute error. Let's see if it's imported. Yes, it's imported. Now again, similar logic, since it is a metric, so we need to get the Y prediction, right? Y pred SGD best is equal to best SGD model we already have. So best HCD model dot predict, and then we will always predict on our test data. So test, and now based on this, we have our y grid if I show you. And now we can use this mean absolute error and pass in our actual value, which is y test, and our y grid HCD, and I can get like 3.81. These 3 more than enough to take, right? So these are the values for this particular question. Now this again becomes a little bit complicated, and this particular section actually ensures hyperparameter tuning. Now let's move on to our next section and look at what else is stored for us. Okay. So now let's move on to our next section, which is mainly about creating pipeline and transformers. So it says, create a pipeline of PCA as transformer and lasso as an estimate. So PCA will work as a transformer to reduce your data, and lasso will be used as a model to train it. And you have to use grid search CV to tune the hyperparameters of the created pipeline, the training dataset. And these lasso, alpha, and on components are part of PCA and lasso. So we will be using it for our hyperparameter tuning. And these scoring 5-fold cross validation and job is equal to -1 will be part of the grid search itself, and we have to ignore the warning which may arise here. Okay, so first of all, we need to import our modules and requirements. So for that, we will be importing few things, mainly pipeline, lasso regression, then our grid source CV and PCA. So for that, we will be using sklearn dot decomposition. Then you have linear model, which is our lasso because it is a regression model. So from sklearn dot linear underscore model import lasso. Obviously, it should be the lasso CV, but since it is told that we need to use lasso, so we will be using lasso only. Okay. Then from sklearn dot pipeline, and then we have a model selection, which is our grid search CV. Obviously, it is not needed to be imported as we have imported earlier, but for the clarity's sake, I'm just going to import it here. Okay. Let's check. We have imported it successfully, and now we need to create our pipeline. For that, I'm going to use variable called pipeline, and then instantiate my pipeline. Pipeline, and the way pipeline works is very simple. It asks for list of name tuples. So here you can have step, but I don't use them often. So best way to do this is just add these curly braces and then square bracket, and within that just do a small enter and you will get a new line. And here you need to pass it inside a tuple. So tuple first parameter takes the name. So here we are using PCA, so I will be using PCA, and then the function itself, which will be a transformer for this one, that is PCA. And next step is our model or lasso. So keep it simple only. So that's why I'm using this lasso directly, and then we are using it. So if it was said that we need to pass in some parameters, we would gladly do that. But since it is not been set, so keep it default. And if I now show you what this pipeline is, then clearly see it's a mix of PCA and lasso. So first input will go to the PCA, then lasso regression model will be there. And the reason that we can fit our model later on is because we are using lasso as an estimator, and estimator has this fit underscore predict method. Okay. So once we have this, now for param grid, I am again going to create a param grid, but for the sake of simplicity, I am going to copy it here and use it. So again, I need to remove these parameters, right? Because I need to instantiate it with new parameters. And here's the important thing. Earlier, we were not using any pipeline, so we were good to go and we can directly access the parameter. But for this, we have our PCA and lasso. So for that, you need to do some trickery. And the way you are going to access these particular individual pipeline object component is adding double underscore. Okay. So for that, you have to do the name underscore, the underscore, then the parameter name which you want. So for example, if I am using this end component, so directly I can't do end component. I have to do PCA underscore and component, and I'm just going to copy it. Now it will understand what you want to do, else it will cause an error. Okay, so make sure that you understand it. And then we have our lasso's alpha parameter, right? To take lasso and underscore alpha, and then we have 10, 1, 0.01 and these values, and nothing much more to do. Okay, so this is done, and we have our param script ready. Now we have to initiate our grid search object. So again, same thing, since everything is almost similar, I'm just going to use the previously defined grid search and add it here. And let's check if we want to change anything. Yes, we need to change this particular thing to pipeline, right? Pipeline, because we are now using pipeline. So everything thing which will enter to our pipeline will be our input data, and it will first go through the PCA transformation and then we will train it on that. This is the thing. And then params grade is same, nothing else. So CV is 5 or not, let's check. Yes, you have to use 5 cross validation. Scoring is negative, mean absolute error. So that is also totally fine. We are doing that. And there is one additional parameter called n_jobs is equal to minus. This helps you to use all the CUDA which are available in your environment or in your GPU. Okay. So once you have done this, it is done. Now let me show you what grid search will do. So you can see that it clearly fits everything, and here is your estimator and everything. Now we are using grid search on top of this pipeline. That makes sure that you understand this. Now I will do a fit x_train, y_train, and then we have to store our best model. So same thing which we did earlier, same thing we have to do here also. Okay, this and this. Which we can get thing. So again, since there are 2 components and there are 2 objects in our pipeline, so it will take a little bit of time. So keep that in mind before anything. And yes, we have our best SGD model. We need print. So let's check. This is our best SGD model giving. Okay, so let's see this. Our PCA has n component 0.95 and Lasso has alpha of 0.0. Now, let's look at the 2 questions which are given. So, if we fit pipeline in the training dataset, what will be the R2 score of the test data? Again, here we will be using similar type of trickery what we did earlier in our first questions, where we were taking just simple X test and Y test and everything. So, right now, if you see, it's already fit for grids, right? And if we set our pipeline for our training dataset, right? So, we will do best PCA model, and I will now print this one, and I will be using this to score our model fit. Sorry, this will not be scored, it will be fit. And then we can do our scoring, right? Because by default it will return the R2 score as it's a regression problem. So now if we do this, we run it again. Then if I do, yeah, you can see that it's 0. Okay, so the reason was we were using a test and y. So that's why I'm saying is that these values are very important. Make sure that you always train on your train data. And now we are good. Our values are 0.628, right? So this marks for this particular question. Now for question number 8, how much variance is explained or eigenvalue by the first principal count? So if you have gone into the theory of PCA a little bit, then you know that the eigenvalue will represent the variance, and the highest variance will be the first component itself. Okay, so for that we can simply do explained variance. And how I'm getting it is very simple. I will do question mark and PCA, and you can see that as I go below and below and below, there will be an attribute called explained variance, right? Which will give us all the variance which are required. And you can also have this explained variance ratio. But since we are using the explained variance and we want an array, so we need this. For this, I will be just using my best PCA lasso model. Let's check what it is. Okay, it's a pipeline. So we are good to go here. And then we need to access the first component. So first component is PCA. So that's why we can access it using like this. Now if you see, it returns a PCA, and then we can use the explained variance, applied explained variance underscore. You can see that we have all these values. Now you can directly get it from here also that it's this, but you need to get the 0th index, right? With index you can do, and you will get 1.635. This will be your answer for this particular question. Now let's move on to our last section and solve few questions from there also. So again, here we are in our last section, and it mainly tests you on polynomial features as your transformers and as well as your estimator. Again, for polynomial features, you have these particular 2 parameters, and for lasso, you have these 2 particular parameters. And again, you will be using pipeline. So almost similar thing, nothing much more. But yes, here you have to import few new imports like polynomial features and lasso. Okay, so let's do that first. So from sklearn dot pre-processing import polynomial features. Okay, now this is part of pre-processing because whenever you will try to fit your data on a very simple data set, it will cause issue. But using polynomial features processing, you can create multiple features from that, like x1, x2, x1 square, x2, something like that. Okay? And after that, we need to import our pipeline from sklearn.preprocessing.pipeline. Again, I'm going to just import it from here itself, all these 2 values, so that we don't have to waste a lot of time here. And obviously, you can also do that animation. or maybe in your interview. And after that, you need to create your pipeline. So pipeline is equal to same thing, nothing else. So once you have defined it once and practiced it, nothing much more is going to change here, except that how you are using it. Okay. So here you can see that we have first our polynomial features. So polynomial features means from here we will be passing polynomial, and make sure you do this right, else it will cause an issue. Okay. So polynomial features basically need interaction only, parameter as false, and degree is equal to 2. Okay. Now for lasso, we need alpha is equal to 1, warm start is equal to, okay, alpha is equal to 1, warm start is equal to true, and our random state is very different here. So make sure that you do that thing also, random state. And once I show you the pipeline, it says invalid syntax. Let's say, okay, it was reason because it's 0 random underscore. So make sure you don't do these type of mistakes. And now if I show you the pipeline, it's done. So this is for our instruction. Now let's solve a few questions. So it says fit the pipeline on the training dataset to find the R2 score of the dataset. Okay. So here I will do pipeline dot fit, and I will be using my training data, that is training features and training labels. So X train, Y train. Now we have our model train. Now we can predict. So pipeline dot predict. It simply says X underscore test on Y underscore test, and it says pipeline dot predict takes true both positional arguments, but 3 way. Okay, it will be scored, not test. So here it's 0.15. Okay. So either you can do this or you can go with the other way, which I showed you earlier. And since I'm not sure, I will just be going here and predicting it based on that. I'm going to check pipeline dot predict will be X underscore test. And once we have our prediction in our hand, we can do our score, and it will be Y test, comma, Y print. And here, make sure that you don't do mistakes. Yes. Now, exactly same. So that way, we are good to go. And now let's move on to our final question, which is 10th one. And here it tests you on recursive feature elimination so that you can get your best features from your data, right? This is very important one also. So make sure that you pay attention here. So from sklearn dot features selection, because we are going to select our features. We are not going to extract right now. So that's why port RFE. This is an algorithm to do this, and it works iteratively. And then here it says linear regression. So we need to import linear regression also from sklearn dot linear underscore model import linear regression. Okay. So once we have imported it, we need to first instantiate our linear regression model. So I will do model underscore len rec, which I usually call my models, and then linear regression, copy pasting everything from here. It says default parameters and estimators, so no issue with that. And after that, I am going to use RFE, and RFE simply use the word RFE and then pass this RFE constructor. We will create an object from here, and it says first of all to pass in an estimator. So estimator is nothing but our model, or you can also use the estimator name if you are getting confused. Okay, our estimator actually model in there. Then we have to set the number of features. So number of features will be nothing but all the features except the last value, right? So we have a parameter called n features select is equal to X underscore train dot shape, and I'm going to just take the number of columns. So that's why I'm using 1 minus 1. And the reason we are using minus 1 is you need to eliminate one feature with recursive feature elimination. So which feature will be eliminated? Okay. And now I'm going to do RFE dot fit, and I will fitting it on my training data, which is process. So process training data is what? It is X train and Y train, right? So that's where we processed our data. X train, Y train. And here we have our RFE, then we have our estimate. Now this is done here, but now the real question is type the index of eliminated feature, starting index from 0. So there are two ways. I'm going to show you one simple ways, and then I will the complex one. So simple way is very easy to understand. You have to use the ranking attribute. So ranking underscore, right? You can see that for the second feature, because indexing starts from 0 in an array. So 0, 1, 2. From the second, for the second feature, it is 2. That means it is giving least importance to this, right? Your second feature will be there. But if you are not sure, you can do this also. Create a new variable L IDX, which simply means eliminated feature index, and then all the list. values which are present in our ranking. We will convert it into list here, and then we will take the index of the maximum value of the ranking. And it simply means that we are doing the exact same thing that we did earlier, but in a more programmatic way. Okay. Now, if I print this value, you can see it's again 2-1. And that's the answer for this question. Though I don't know this particular method is actually right or wrong. So please let me know in the comment. So guys, this marks the end of this particular lecture, and I hope that you have learned a lot, and please practice it, because most of the times you will be doing this over and over again in your particular machine learning project. So this is not just for an examination, it's also for your future work. So make sure that you understand all of this. And if you're liking this video, please give it a thumbs up and subscribe to the channel, and do share it with us. Maybe it will help others also. So see you in next video. Till then, bye-bye.